In this chapter, we look at AutoML from a human point of view. AutoML is very good at finding strong configurations of machine learning algorithms on its own, but most of the time it hands us an answer without telling us why that answer is good. This chapter is about opening up that black box so people can understand, trust, and steer it. Let's start with what AutoML actually does. We give it a search space of possible configuration, and it looks for the one configuration that gives the lowest cost. And it works. What we get back is usually a very good configuration. But what we don't get, we don't learn which hyperparameters actually mattered. We don't know how fragile the result is. Would a small change hurt us a lot? We can't easily tell whether the result is trustworthy or just a lucky artifact of the search, and we get no picture of what the optimizer tried before it settled. So the black box gives us results but no understanding. That gap is the whole motivation for this chapter. Here's the subtle problem that comes with automation. AutoML lowers the barrier to running machine learning, but not the barrier to using it well. Think about how it used to be. If you had to train models by hand, that difficulty was actually useful. It forced you to understand your problem before you could even get started. You had to think about your data and your goal. AutoML removes that friction. That sounds great, but it means that decisions that specialists used to make, often without even noticing, now get skipped entirely. Some of those are mechanical. Which optimizer, what learning rate, which kernel, AutoML handles those well. But others are real judgment calls. What should we even predict? Whose data should we use? What does good enough mean? What is the real use case? No search algorithm can answer those for us. So automation makes the easy part easier and quietly hides the part that still needs a human. So what do we mean by human-centered AutoML? The goal is to make AutoML interpretable, trustworthy, and interactive for the people using it. It helps to compare it to explainable AI. XAI explains a model's predictions. Why did the model label this image a cat, for example? Human-centered AutoML is one level up. It explains the AutoML process. Why did AutoML end up here? There are two different things we might want to explain. First, the final configuration. Why are these hyperparameter values good and which ones matter? Second, the optimizer's behavior. How did it move through the search space? What did it explore and what did it ignore? Keeping these two apart, different tools answer different questions, and we'll see several of them in this chapter. It also connects to interactive AI. The idea is to bring the human back into the loop, so informing by these explanations, their intuition and domain knowledge can be brought into this process and together with the AutoML tool work together and achieve better results than ever before. So why do we even want humans and optimizers to collaborate? The answer is simple, because they are good at different things and we would like to leverage that potential. Human intuition is valuable. It's great for warm starting a search, for spotting abstract patterns, and for remembering what worked on similar problems in the past. What humans are not good at is carefully searching a huge high-dimensional space of settings. We simply get lost. Optimizers are the opposite. They're excellent at systematically traversing high-dimensional spaces, but they don't have prior experience or common sense about your specific problem. So the picture here is, let the human give good starting points and priors and let the optimizer do the heavy, careful searching. Human-centered AutoML is about making that collaboration possible. To wrap up the big picture, first, AutoML is not self-explanatory. It gives you a strong configuration but without insight into why it works, which limits trust and makes it hard to carry lessons to the next problem. Human-centered AutoML exists to close that gap. Second, explanation is not a single thing. We care about local versus global views and about single effects versus interactions between hyperparameters. Different questions will need different tools. Third, it's not only about explaining the final answer. Understanding how the optimizer search is valuable too, because it reveals biases and can make future runs better. In the rest of the chapter, we will go through concrete methods that deliver these explanations. And finally, ways to bring user knowledge into the optimization process itself.